Okay. Alright, so now what we will do is we are going to go through a couple of different equations and we're going to try to find a suitable quadratic equation to model this bridge. Okay, so first of all, we would like to get some measurement happening and some sort of axes so that we are able to relate the points on the graph to each other. So whether we want 0 degrees for the x-axis. So what I can do maybe is I'll choose what color would stand out nicely. Let's say orange. Okay, so with the orange color, then I will just go right across here, and I'll leave it at there, at that. So what we have is this is called the x-axis. X-axis. All right, and then on the x-axis we have various points. So I can label them, maybe choose a slightly different color here, this one. And here, if we say this right here is 0, here I have 1, 2, 3, 4, 5, 6, 7. Okay, so approximately 7 units to the right here. To the left, we also have again 1, 2, 3, 4, 5, 6, and 7. Okay, so again, approximately 7 units to the left. So here we have the bridge coming in here, and like we see on the right hand side, we have it over approximately over here. Okay, so that point right there, this point right there is -7, as this here was 0, right across here, and on this side we have 7. Okay, so -7 and 7, and then when we're looking to the y-axis, as the vertical axis, we want to make it like this: 90 degrees, come at 0, draw a nice line, probably do it again in a bit darker color, and we go upwards, back down. Okay, this here is our y, y-axis. Okay, so we have our x-axis, we have our y-axis, we have the general shape of our Cartesian plane, a graph. And now what we want to do is also we want to see along the y-axis how many units we have until we reach the y-intercept, which means where the bridge crosses the y-axis. Okay, so what we have is, it is right here. So if this here is at 0 over here, okay, slightly different colors, so we can see the yellow, here's 0, so 0, up here we have a 1, and here we have a 2. Okay, so at this point right here we have a 2. All right, so the 3 things we have, the 3 points that we know are the following. So one is we have -7, 0. So this is the Cartesian form. So the x and the y. So -7, 0. On the right side here we have 7, 0, 7, 0. Okay, because on the x we have 7, and on the y it's nothing, up and down as you look down here, so it's on 0. So therefore here it's 7, 0. And the last point that we have here is this one over here, which is 0, 2. So 0, 2. Okay, so these 3 points, they're going to be very important when we go on to solve or to find appropriate models, appropriate equations, appropriate functions that will represent this bridge. So the way that it should look like is it would be a line called a quadratic equation, and it will look something like, so it will be starting here. Black is probably not the best color. Let's do a white, and let's do a bit of a thicker white. So it will be coming through here, be passing through 2, come out on the other side, we'll actually pass through, and we'll come down to here, down to 7. Okay, so that is the general, that is how the equation will look like. All right, and now our aim is to find out this equation, or possible potential equation that can represent this quadratic function. Okay, so to find the quadratic model, what we want is, there are 3 types of quadratic models. Okay, so what I will do now is I'll write them on the right hand side. Okay, so 3 types. So one is called the standard type, or the standard form. Okay, so with the standard form, the way that looks like is like this. Y is equal to ax squared plus bx plus c. Okay, and where in this equation we have a, b, and c, they are just constants. Okay, so they are just numbers that don't change, and the x and the y are variables. All right, so this is the standard form. Another form that we can have is the Vertex Form, which is based around the turning point. Okay, which in this case will be our 2, 0, 2. The point 0, 2 will be our turning point. And the way that this equation looks like is the following. Y is equal to, we can say a, it's a constant at the front, and then we have x minus h squared plus k. Okay, so that's the vertex form. And the third type, okay, is called the Intercept Form. And the way that this will look like is like this. Y is equal to, we can say a at the front as a constant, x minus p bracket, that's one factor, and the other would be x minus q. Okay, so here we have 3 types of equations that we can start off as a base, and from these we'll be working out, we'll be substituting numbers, and we'll be working out potential quadratic equations that we can use for modeling this bridge, the Sydney Harbour Bridge.